Reinforced concrete versus prestressed concrete. Today, we will explore the fundamental differences between these two concrete systems used in civil engineering, understanding how each system overcomes concrete's inherent weakness in tension. Concrete is an excellent material in compression, typically withstanding 40 megapascals or more. However, its tensile strength is only about 1/10 of its compressive strength, around 4 megapascals. This fundamental weakness means concrete cracks easily when subjected to bending or tension. Engineers have developed two primary solutions to overcome this limitation: reinforced concrete and prestressed concrete. Let's explore each system in detail. Prestressed concrete takes a revolutionary approach. Instead of waiting for loads to create tension, engineers pre-compress the concrete before it enters service. Think of it like squeezing a stack of books together. The compression allows them to act as a single rigid unit. In prestressed concrete, high-strength steel tendons are stretched and anchored. These tendons constantly try to contract, which compresses the concrete. This pre-compression counteracts or eliminates tensile stresses that would occur under load. The result is a much more efficient structure with greater load capacity and longer spans. Let's compare these two systems. Reinforced concrete uses mild steel with strengths of 250 to 500 megapascals, while prestressed concrete uses high-strength steel of 1500 to 2000 megapascals. Reinforced concrete is passive, reacting only after loads are applied. Prestressed concrete is active, with pre-compressed concrete before loading. Reinforced concrete shows visible cracks under service loads, while prestressed concrete remains essentially crack-free. Typical spans for reinforced concrete range from 5 to 10 meters, whereas prestressed concrete can span 20 to 50 meters or more. Reinforced concrete has lower initial costs, while prestressed concrete costs more initially but offers lower long-term maintenance costs and greater structural efficiency.